Hey guys, and today we are going to be looking at graphing exponential functions and then looking at the growth and decay of those functions. So we're going to do an intro video to that, and then you guys have some assignments to work on as well. So let's go ahead and dive into what we went over on Zoom today. I need to change that because Zoom's definitely got changed to 8:30 in the morning. So we did a little reflection on yesterday's assignment and what did we discover about the different scenarios. So in scenario number 1, whenever you were given 1 point every single day, we realized that by the end of the week, we would have a total of 14 points, only because you're only given a point every single day. Versus if the points doubled, that was going to grow exponentially, or it would be a greater increase or a greater, not decline. It was going to increase rapidly, which brought us to an exponential function and not a linear one anymore, where it was just increasing by the same number every single time. So today we really looked at that in our tables as well. So I'm going to go ahead and go through y equals 3 to the x power. So we're going to go ahead and dive into that. So I'm going to be looking here, and we are doing 3 to the negative second power. Okay, so remember those negative exponents. It's really 1 over 3 to the second power, and 3 times 3 is 9. So our y value is 1/9. This one was 1/27, and then you also have an x value out there, which was -3, and then the y value is 1/27. Okay, so then if I do 3 to the negative first power, that's really 1 over 3, which is 1/3. Remember, anything to the 0 power is just the number 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power, which is 3 times 3, is 27. Okay, so as I'm looking at this table, I'm going to go ahead and just erase this piece so I have room to write the pattern that I see happening. And I'm one I like the whole numbers to see the pattern at better. And then we'll go back to the fractions in just a second. So I'm noticing that from 1 to 3, I'm used to finding the difference or the number that I'm adding, okay? So if I go from 1 to 3, that's 2, but 3 plus 2 is not 9. So adding is not working on this particular problem. So let's take a look at, multiplication, because remember, I'm multiplying by another number because my exponent is increasing, where this one was 1/3, this one was 3 times 3, and then this one you multiplied by another 3 to get 27. So the pattern that is happening is you're multiplying by another 3 as you move down your table. Same thing with the fractions. 1/27 times 3 is 1/9. 1/9 times 3 is 1/3. 1/3 times 3 is 1. So if something is being multiplied by that base or a particular number, my equation, my graph, is going to increase very, very quickly. So if I was to graph these, I'm going to graph the point over here, 0, 1, and then I'm going to graph 1, 3, 2, 9, and then 3, 27 would be like all the way off there. So as you can see, that wasn't straight either. It wasn't linear now. It is increasing rapidly because we are multiplying. It's gonna, maybe, kind of. Okay, there we go. And if we go into Desmos.com, so for the purpose of assignments, let's make sure that we're going to Desmos.com, going into those math tools and going to the graphing calculator. The graphing calculator in your Google Classroom is the testing calculator, so you won't be able to download the graphs and put them into the Google Doc for the purpose of the assignment. So you guys feel free to go to Desmos.com, go to the tools, and then go back. So I'm at Desmos.com. I went to the math tools and inside the graphing calculator. If you sign in with Google or log in with Google, it'll save everything that you do. Or if you want to just continue to use it as a guest, that is fine. Remember, this is your share graph button, and you're going to export the image to put it into your Google Doc assignment for today. But enough of that. We're going to be diving into y is equal to 3, and we're going to use the exponent. We're going to use the exponent x. Okay, so some things to look at on this particular graph is there is a y-intercept of 1, and my graph is increasing exponentially, rapidly is another word for that. And then something else to notice is it is not touching that y-axis. Although it looks like it, I can't get close enough so you all can see. It doesn't officially touch 0. So that new vocabulary word is an asymptote, and we're going to be looking at that a little bit more in depth later. But the key part of this particular graph that I want you guys to really notice is it was increasing exponentially, rapidly, because we are multiplying by 3. Something else to really look at as it was growing. So it started like from left to right. As I read it, it is growing, it is increasing. Okay. Now, remember my base was 3, so on the next one, we're going to look at that in a little bit. So that was just an introduction today. So on the next one, look at my base. It is 1/3. So if I do 1/3 to the x power, I'm going to need the web paint because I took off the screen for Castify tools. Color, red. Okay, so if I do 1/3 to the negative third power, 1/3 to the negative second power, 1/3 to the negative first. Okay, so 1/3 to the negative third power. Remember that those are negative exponents, so you kind of got to flip-flop those around. That number is going to be 27. So in reality, it's 3 times 3 times 3. 1/3 to the negative second. Remember that negative exponent rule is 3 times 3, which is 9. You have 1/3 to the negative first power. Remember your negative exponent rule. So that 1/3 becomes a positive 3 to the first power, which is 3. Now we have 1/3 to the 0 power. That is 1. We have 1/3 to the first power. That is 1/3. We have 1/3 to the second power. That is 1/9. And then 1/3 to the third power, and that is 127. So something that I'm noticing here is let me get a different color. I am decreasing now. And so with our particular functions, we're going to use the word decay to explain that. So I'm decaying, or I'm decreasing by 9. So every single time I'm dividing, let me say dividing. So it's going to be nope, I'm not dividing by 9, I'm dividing by 3. Divide by 3 every single time, and I'm decaying. Decaying rapidly, actually, as well. So as I put this into Desmos, we're going to really be able to see what a decay looks like compared to a growth. So I'm going to take this out. I'm going to use my keyboard so I can put in a fraction. Let's do 1 divided by 3. And then make sure you click off your cursor here. Use the exponent, and then we're going to use the letter x. So as you can see with this one, let me move this out of the way. I started, if I'm reading from left to right, I started at an increase, and then I went down, or I decayed, I decreased. And so some important pieces to realize the difference was whenever my base was bigger than 1, when the previous one it was 3, it grew, or it was an exponential growth. This one we had 1/3, which is less than 1, and that was a decay, or a decrease. So I'm going to clear off that slide. Skip these two for a second, and I want to go to our exponential function. So anything that the x is, let me use the word attached to, or b is your base, you're going to look at that for your growth or decay. The next part that we're really going to dive into is, can there be a y-intercept? So the graphs that we just looked at, there was a y-intercept. If I zoom in, my y-intercept was the number 1 because that's increasing by half. So my y-intercept right there is at 0, 1, but can my y-intercepts be anything else? Let's go ahead and look at this one. So if I do 8 times 1/2 to the x power, so for, that is looking like 8 times 1/2 to the negative first power. Okay, then you're going to do 8 times 1/2 to the 0 power, and then 8 times 1/2, 8 times 1/4, because it's going to, like, the 1/2 power is increasing every single time. So I went ahead and did these values to, like, help speed the video along. So here your y value is 16, 8, 4, 2, 1, 1/2, 1/4, and 1/8. Okay, and I kind of knew that it was going to end up decreasing or decaying because my b value, or my base to, I didn't switch the color, my base to my exponent was 1/2, which is less than 1. Okay, something else to look at is that y-intercept. And so right here, anytime x is 0, that's a key indicator of where your y-intercept is located. So x is 0. So it's saying my y-intercept is 8, and look right there at the number that I multiplied by out in front. Okay, so now let's dive into Desmos.com so we can see what it looks like on a graph. Pull the graph back out. So we're going to do y equals 8. We're going to multiply that by 1 divided by 2, and we're going to raise the 1/2 to the x power. Okay, so as I graph this one, if I go up here, I have the y-intercept right there at 0, 8, and then down there it was 1, and it was identified in my table. It was also identifiable in my equation as well. Okay, let's do one more before we wrap up this particular video. On this one, I now have 7/2. If you want to, you can go ahead and change that fraction there, if you want to the decimal 3.5, because 7 divided by 2 is 3.5. Times 2 to the x power. Okay, I went ahead and worked out these particular numbers for you just for the purpose of the video, for it to not be as long. So we had a bunch of decimals or fractions down here. Whenever I plugged them into the calculator and did my calculations. And something that I'm noticing is I'm growing. So I'm getting larger and larger as I am, that's not the right number, as I'm moving down my table. Okay, and again, I kind of knew that I was going to be growing or increasing because my base to that exponent was a whole number. It was bigger than 0. Okay, now so another key feature to look at on that table is anytime, remember, that x is 0, that is an indicator or a way to identify your y-intercept. So it's saying that my y-intercept is 3.5, which was in my equation right here. Now technically, it's also 7 divided by 2 as well. Okay, so now let's dive into Desmos.com. And let's graph this. I'm going to go ahead and use 3.5 if you guys are okay with using that as a decimal. So 3.5. And then we did times 2 raised to the x power. And looking at this on the graph, I see that it's growing because that 2, which was the base, was greater than 0. And we also have a y-intercept at 0, 3.5, which is what my particular function was being multiplied by. So on the next slide, we're going to go through some key takeaways from today's lesson. So your general formula for an exponential function is y equals ab to the x power. The base is what you're going to look at for your growth or your decay, and anything that is being multiplied is what you're going to look at for your y-intercept. So what I mean by that is if I have the particular function y is equal to 3x, like we started with before, and then y is equal to 1/3 x, like we also graphed. We also graphed y is equal to, I'm going to use 8 times, nope, I'm going to move that down. Y is equal to 8 times 1/2 x. And then I did y is equal to, I'm going to use 3.5 times 2x. You could also see it written as 3.5 times 2x like this instead of the dot for multiplication, or 8 times 1/2 x like this instead. Oops, except for that dot. It's not supposed to be there. The parentheses instead of the dot. Okay, so let's dive into our key functions, our features here. So we're always going to look at my base for the growth or decay. So 3 there we go. Okay, so 3 is my whole number. It is greater than 0, so this one right here is going to be a growth. 1/3 is less than 0, so that is going to be a decay. 2, greater than 0, and that is the base of that exponent. That is a growth. 1/2, less than 0, that is a decay. Okay, now it's time to look at that y-intercept. So they could get a little bit tricky. I'm going to say that A is pink just for the purpose of this video. And so here, there's not a number that's being multiplied, but don't forget about that understood 1 being there. So technically it's being multiplied by 1. So your y-intercept is 0, 1. And for the purpose of the Google Form assignment, just put the number 1. On this one, again, there's that understood 1 in there. So your y-intercept is 1. Here, it's being multiplied by 3.5. So your y-intercept is 3.5. Here, my particular exponential function is being multiplied by 8. So that y-intercept is 8. Again, at any time that you're like, I don't know whether it's growth or decay, I don't know which part of the equation or the form, the function form identifies growth or decay or the y-intercept, come back to these Google Slides and your lesson materials for March 15th through 17th. If you're watching this video during the 2021 school year, that's where it is located, but you have y is equal to ab to the x power. A is where you identify the y-intercept. B, it helps you identify growth or decay. And then with x being your exponent, variable being your exponent, it makes it an exponential function. So I hope this video has helped. If you need me, remember I'm just a private comment away on Google Classroom, or you guys can shoot me an email. Best of luck on today's assignments.